So for A class, I think you didn't see. So after completion of the syllabus, if time permits, we'll be seeing some videos on the working of steam power plant also. Now today, so we are going to see about this hydropower station. Okay. Because hydropower station I've taken, but I didn't even shown some videos. So in this class, we are going to see some videos on hydropower station.
Hydroelectric power plant. Hydroelectric power plant. In a hydroelectric power plant, electricity is produced from water. The dam is built across a large river to hold back the river water and raise its level to form a reservoir. At the bottom of the dam, there is a floodgate. Water flows through the penstock and rotates the turbine. The flowing water rotates the turbine, which is placed at the end of the penstock. The turbine, in turn, rotates the shaft that is connected to the coils of a generator. These coils are placed in between strong magnetic poles. The rotating shaft turns the coils. A change in magnetic field due to the movement of the coils results in electric current. Hydro
These are all very small videos.
Hydroelectric power plant. In this session, we will study about hydro energy, review the history of hydroelectric power plant, study the working principle of hydroelectric power plant, and specify the advantages and disadvantages of hydroelectric power plant. Hydroenergy. Hydroenergy is the energy generated by the force of water. This is a powerful way of generating electricity. The hydro energy is converted into electric energy by hydroelectric power plant, and this energy is called as hydroelectricity. History of hydroelectric power plants. World's first hydroelectric power plant was built across the Fox River in Appleton, Wisconsin in US in the year 1882. India's first hydroelectric power plant was commissioned in 1887 at Sidrapong, Darjeeling in West Bengal. India's largest hydroelectric power plant is located across the river Koyna in Maharashtra. It has a...
So I just want to add some points over this. So in India, if you see like which is the longest river in India. So the first one is Indus River, River Indus. Okay, so if you see the map, I'll just share some view. Yeah. So if you see this this river Indus, so where it is starting from here, the western part of the that is Himalayas, that is Tibet. Okay, and it is flowing like this. It is flowing to Kashmir, and it is coming flowing to Pakistan. This part is full of Pakistan. Okay, so starting from here, okay, but it is starting from India and passing over through Kashmir, Jammu Kashmir, and next to this Pakistan, and it is flowing through this, and it is passing all over to this Pakistan, and again at last it is okay, joining at the Arabian Sea at Karachi. Okay, near to the Karachi, it is the river is that okay, water is flowing through this Arabian Sea. Okay, so this is the first longest river in India. Okay, but even though it is the origin point is from India only, so this is the first longest river, approximately 2,900 kilometers. Okay, so second river, if you see, which is the second river, any idea? Second longest river. Yeah, the yeah, the second longest river is river Brahmaputra. Okay, so it also starting from here. Okay, it also starting from the this part. Okay, then Tibet exactly at Tibet. Then it is flowing to China. Okay, it's flowing to China, starting from India and flowing to China. Okay, so after that it is passing over to this part, Arunachal Pradesh, this part. Okay, so again coming to Bangladesh and next to like West Bengal, and it is okay. Okay, it is flowing through this path, and after West Bengal, it is going to Bay of Bengal. This water is going to Bay of Bengal. So this is also second largest, longest river in India. So the distance is approximately 2,700 kilometers. 2,700 kilometers. It is flowing to almost two nations, two or three nations, like Nepal, China, then Bangladesh. Then after that, again to India. Okay, starting from India, and again it is flowing to this many countries, and again it is coming back to India. So here only this China, they are planning to build a very huge dam. Okay, so if they okay, if they build a dam here, then this river will not flow through this part. Then we will not get okay this water at this places. That is in Arunachal Pradesh, and as well as in West Bengal. This area will be somewhat rough. Okay, because many agriculture activities are going on over here. So this is one of the issues now it is going on. So next, third longest river. Okay, which is the third longest river? Third longest river. Yeah. So the third longest river is River Ganges. Okay, River Ganges. So it is starting from this part, Himalayan part. Okay, western part of Himalaya, western part of Himalaya. Okay, and it is flowing. Okay, flowing almost five states, 3, 4, 5 states. It is flowing. Okay, this part it is flowing. So this is approximately 2,525 kilometers. Okay, 2,525 kilometers long. Okay, So this river only flowing throughout the India, that is in and around the inside the India. Okay, other rivers are originating from some other places and flowing in India and okay, going to some other countries. But this river only flowing in our country, okay, inside our country. So here in this belt, if you see many of the hydropower plants they have installed, okay, in every state, okay, they have installed many of the hydropower plants because even this is the ever-flowing river in India. Okay, so that is it is flowing inside the India, so it is a ever-flowing river. So always like 320 days, you out of 365 days, you will get almost 325 days. You may get the water. Okay, so you can generate the hydropower station is plenty in this belt, in this river belt. You can find more hydropower plant. I think we'll discuss in detail the what are the power plants, hydropower plants, everything in the final year, in the subject power system operation control. So here, this is the out of scope, like where are the hydropower plants like that. So this you can see in you can browse in the internet. So there are many hydropower plants, and it is passing through almost Uttar Pradesh, then Madhya Pradesh, this region, then up to West Bengal. Okay, and again it is touching this path, that is Bay of Bengal. All the water is okay going to this path, that is Bay of Bengal. It is stopping. Okay, so these are the three longest river in India. You can find most of the hydropower plants in this belt. Okay, in this belt you can find. So next we will continue this video.
Capacity of producing 1920 megawatt electricity. Bhakra Nangal is the biggest dam in India as well as the world's highest straight gravity dam. The working principle of hydroelectric power plant. In this power plant, production of electricity depends upon the height of the water from ground level, volume of the water flowing per unit time, and efficiency of the turbines. Hydroelectric power plant requires a water reservoir. So these plants are constructed near big dams. Water stored in dams has potential energy. The water under pressure is carried by penstock and supplied to the turbine through the inlet valve. Penstock is a pipe made up of steel or concrete. A surge tank reduces the excessive water force on the penstock. Here, trash rack prevents the debris from getting entry into the powerhouse.
So this trash rack, so exactly this trash rack you'll be finding in many of the dams. If you see the dams, you can find this trash rack. Okay, so if you go inside the power plant, you'll be in some dams you can see this trash rack of very big structures. Okay, so some debris and some stones might be there, some plastic waste might be there, like in the dam. Then some sand or mud, some parts. If it is it is not with this trash rack now, automatically the stone and everything is flows and hitting that your turbine runners. So that runners may get damaged. Okay, So due to that, the power production also will get affected. So this trash track they may install for removing the debris. Okay, so this is of civil structures.
House. Due to the force of water, the turbine starts rotating, due to which mechanical energy is produced. The shaft from the turbine is connected to the generator. Therefore, the generator produces the electricity. The voltage of this electricity is raised by using a transformer and is transferred by the distribution lines. After running the turbine, the water is passed to the downstream water level by draft tube. The demand of electricity varies by day and night as well as among the seasons. Hence, there is a need to store the energy so that it can be used at the time of high electricity demand. This can be done by using pump storage process. Advantages and disadvantages of hydroelectric power plant. The most important advantage is that it keeps the environment clean. Hydro energy can be stored in high-level reservoirs and used whenever necessary. Electricity is produced at a constant rate. The life of dams and power plants lasts for many decades. The water can be used for supplying drinking water, irrigation, water sports, industries, power plants, etc. Another advantage is that when electricity is not needed, then the sluice gate is closed to stop the generation of electricity. It also allows storage of water to be used whenever necessary. However, the disadvantage is that constructing power plants and dams is very expensive. It requires large area. Another disadvantage is that planning a hydroelectric plant and reservoir may lead to the disruption of the lives of people living in that area as they have to reallocate to another area. In this session, we learned about
see next video.
Hello friends. Now cycle. Take a look.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine.
So this distance, if you are going very steep, you will get more amount of velocity of the water. Okay, so if it is this distance is very less, or it's not that much steep now, you'll get that much pressure on. Okay, so in this animation video they have shown like that. But even if you see, like majority of the hydropower station, they will be constructing even like 1 kilometer, 2 kilometers. They are going into very, very steep. Okay, their angle from the dam to that okay, generation stations, that angle might be of like 45 degree, 30 degree. Okay, so and also they are going very, very steep. Okay, very long kilometers. Distance might be of some stations are all there like 5 kilometers. Okay, that penstock might be of 5 kilometers, 2 kilometers, like that. So how many kilometers you are going down steep? Okay, that angle of elevation, how many distance you are going down, that much pressure you will get. That is the main thing in constructing this hydropower plant. Okay, you can't simply construct the hydropower plant near to your house like that. So so you have to dig a deep okay valley like that thing. Then you have to construct the generators, hydropower station in that area. Then only you can generate more power, like 100 megawatt, like 200 megawatt or 500 megawatt, like that you can generate more power. Or otherwise, uh, this thing. So it might be a have series of penstock. That might be not having only one penstock. It might be having series of penstock. Okay, so maybe this generator is having the capacity of 100 megawatt. Similarly, another one penstock. So like 5 penstock, 10 penstock might be there. Okay, so depends on the amount of the water. They might be deciding how many penstock, like sluice gate, we have to on. Okay, so here there might be a sluice gate of that is called okay like ball house. Okay, so that in ball house only they will be having the sluice gates. Okay, if the gate is opened only, so we have seen in the previous video, no, if you open the gate only, water will flow to that penstock. So that also there. So series of penstock might be there. So today we want 500 megawatt means, so this generator is of 100 megawatt means, so five penstock you should on, or like that you should on 5 penstock. Okay, so which generator is in operation in good condition, that penstock alone they will on. That sluice gate alone they will on. Like that particular time for 5 hours, 8 hours, or 10 hours, like that depends on the demand. They may generate the power.
Water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water.
So if the river is flowing from a mountain, okay, if the river is flowing from a mountain, so in this kind, the runoff river power plants, they will be installing this runoff river power plants. Okay, so this runoff river power plants, so no need of storing the water and all. Even the flow of water itself. Okay, so in the first stage itself, we are generating the power runoff river power plant. In the first stage. Okay, after that, flowing water will again store in the dam. Next, the second stage, we are generating some power. Like that, series of generators might be there. Next, that water will flow to the third stage. Third stage, some capacity of dam will be there. There also we are generating. So fourth stage, fifth stage, like that, many stages. So if it is located in the hilly areas, you can make this as a stage by stage. Or in plains also, you can construct the dams like that. Okay, the first stage of dam, if it is water is opened in the first stage of dam, it is flowing to some 10 kilometers or some after some time, so you'll be finding another one check dam, and that check dam you will be storing some water. So again some generation is happening. So again the water is flowing from out from the dam. Again it is flowing to some 5 to 10 kilometers. Again another one dam, like that. So like that, we are extracting maximum power out of that. And nowadays we are installing a mini hydro power plants of 10 megawatt, 15 megawatt, 20 megawatt. So whatever the size, it may be 5 megawatt. Okay. So the thing is that we want power. Okay. So we don't, because water, so in southern parts of India, some scarcity of water is there. Okay. In northern parts, so 3 rivers are there now. So there might be not that much scarcity, but even though in some places is there, but in southern part of India, only if it is rains, then if the flow of water in the river is good, then we can generate the power. Like that, we are dependent on the season and the flow of the water in the river. So in this scenario, we are extracting maximum power out of this
through turbines.
river.
Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even
So
though
in India, hydro is second only. Only we are dependent on coal, the most of the reserve. But if you take in some of the foreign countries, in other countries like US, they are mostly dependent on first hydro, next is renewable, next only thermal, then nuclear, like that. So in India, the case is somewhat reverse. Okay, so hydro is somewhat less only. Second largest. First is we are mostly depending on coal. Okay.
Initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Another one video.
$170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall, or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called a stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
Yeah, that's all about your hydro power station.